Today we're talking about calculating sine, cosine, and tangent functions. In a right triangle, we've already used sine, cosine, and tangent to find the ratio of two sides. So if you don't know what sine, cosine, and tangent are, this video is not for you yet. And now we're going to use those same trig ratios to help us find the length of sides we don't know. So we're just going to jump right into our examples. In example 1, notice I know the hypotenuse is 10 centimeters. I know that I have an angle measure of 40 degrees. Of course, this is a right triangle, so I know the 90-degree angle measure, but that's not really going to help me. And I need to find x, which is another side length in the triangle. So in this topic, you need to put a little bit of thought into it, I guess is what I'm trying to say. You need to notice, for instance, that you need to find the side adjacent to the 40-degree angle. And you know the hypotenuse. Which trig function uses adjacent and hypotenuse? That would be the cosine function. So we're going to use cosine to set up a little equation. The cosine of that 40-degree angle is x over 10. This is the equation that's going to help me find x. So this says x divided by 10. How am I going to get x by itself? I'm going to multiply both sides by 10. That's going to cancel the 10s on the right-hand side or reduce them out of our way. And I get x is equal to 10 times the cosine of 40. So now I need to have a scientific calculator. So we're going to bring in a scientific calculator. Remember, there are two types of calculators. So if you have a different type of calculator, it might work a little differently, and we can go over that in class. So I'm going to do 10 times, on this calculator, I have to put in the 40 before I hit cosine. Then I'm going to hit equal. 10 times the cosine of 40 degrees is about 7.66. And that is my missing side length. So my missing side length is about 7.66 centimeters long. Let's try another one. So Leo is building a concrete pathway 150 feet diagonally across a rectangular courtyard as shown. So this is my 150 feet sidewalk or pathway. We want to know what the length of the courtyard is, so we want to find x to the nearest thousandth, and it gives us that we have one angle that's 34 degrees. So first of all, our right angle is going to be down here in the right corner. So if I'm looking at 34 degrees, I know the hypotenuse, right? 150 would be the hypotenuse. What other side do I need to know? I'm missing the side opposite of 34. So I need to know the side opposite. I know the hypotenuse. Which trig function is it that uses opposite and hypotenuse? That would be sine. So I'm going to set up a sine equation. The sine of the 34-degree angle is x over 150. To get x by itself, I have to times both sides by 150. So x is going to be 150 times the sine of 34 degrees. And again, in comes our calculator. So this time I'm going to do 150. This is a very loud calculator, sorry about that. Times the sine of 34 degrees. Then I'm going to hit equal. and I get rounded to the nearest thousandth, that's 3 decimal places, I'm going to get 83.879. And that's my missing side length. My the width of my courtyard, or sorry, the length of my courtyard is about 83.879 feet. And here we have a trucker driving up a hill. He drove for 1,027 feet. The hill has a constant slope since, in a triangle we really need a constant slope. When the trucker reaches the top of the hill, he's traveled a horizontal distance of 990 feet. At what angle did the trucker drive to reach the top? So this one, still, we're going to set up our equation the same, but there's going to be a little trick to it at the end. So we know the side adjacent to my angle and the hypotenuse. Which trig function uses adjacent and hypotenuse? That's cosine. So I'm going to set up a cosine function. The cosine of angle W is 990 over 1027. Now, here comes the tricky part. I can't, x is not over on the right-hand side. It's not part of my actual fraction. It's an angle measure that I don't know. So this actually is when the inverse trig functions come in. Inverse trig functions, like the cosecant, the secant, and the cotangent, those are to help us find degree measures. So this is how it works. If I'm finding the cosine of W, then the inverse cosine will help me find W. And this is how I set it up. I'm going to take the fraction on the right, I'm going to take the inverse cosine of that fraction, and that's going to help me find the angle measure. So, on your calculator, you're going to have, of course, one of two types of calculators. Remember, calculator type 1, you can actually see the word cosine on your calculator display. Calculator type 2, you can't see the word cosine on your calculator display. On both calculators, of course, make sure your calculator is in degree mode. On calculator type 1, you're going to do second cosine, and on your calculator display, it's going to say cosine to the negative first power. It should give you an opening parentheses. If it doesn't, type 1 in, then put 990 divided by 1027, close parentheses, and then hit enter. On calculator type 2, do the division first. So 990 divided by 1027, and don't clear the screen. Then you're going to press the second button and choose cosine. That's going to give you the inverse cosine. Don't hit enter. What's on your display is going to be the degrees for angle W. It did ask us to round to the nearest whole degree. Keep that in mind. So you should get about 15.426. So to round to the nearest degree, that would be 15 degrees. The truck was going up at a 15-degree angle. Okay, one last example. Oops, this was example 4, I think, instead of 3, but oh well, we'll get there. In triangle TRY, that means that your points are T and R and Y. Angle Y is the right angle. And the tangent of angle T is 8 over 15. So since we know the tangent, and that's going to be opposite over adjacent, let's put those sides on our triangle. Opposite is 8 over adjacent, which is 15. What it wants is the sine of r. So now we're going to switch over to its complementary angle. Sine, of course, is opposite over hypotenuse. I don't have all the information I need. So remember, when we know two sides and need to know a third, that's when Pythagorean theorem comes into play. When I use Pythagorean theorem, I find that my hypotenuse is 17. Now I can find the sine of r. Sine of r opposite over hypotenuse is going to be 15 over 17, which is about 0.882. When it asks you to solve a right triangle, okay, we're going to actually do this example in class together, but when it asks you to solve a right triangle, it is asking you to find every side length and every angle measure. That's what it means by solving a right triangle. Have a great day. Don't forget to take the quiz, and definitely bring your notes to class. I'll see you later. Thanks a lot.